Hi, yes, I'm Ray. Thankfully, the room's emptied out a little bit, so I don't have to be quite so nervous as I was beforehand. I'm not going to be showing you much JavaScript code, I'm afraid. So if you want to see a lot of JavaScript code from Toyota, then maybe you should go to the next room. I'm going to start about something that we've been working on as a company for the last 100 years. And that is these things, the cars. Okay? This is the one example which I thought might impress JavaScript developers. Most car companies, most equipment manufacturers, most people in the manufacturing world think about this kind of thing, which is a product, and this product doesn't have anybody in it. If you can notice this, you'll find that most of the manufacturing brochures for almost all equipment is without people, because most original equipment manufacturers really care about the product. And once it goes outside of the factory, it goes to some distribution network, and then other people deal with the people who drive these cars. And we can see a nice lady here in a car, that's good. We can get some people into cars. We know that's happening in a dealership somewhere, but we don't really know much beyond that. Now, something about this picture you might recognize, apart from the fact that we've concentrated mostly so far on the steering wheels and on the dashboards and on the kind of engines and all that kind of stuff. But now we have these new things in the cars will allow us to serve the customer a lot better and to really understand what they're doing in a better way. So this actually changes the game for equipment manufacturers, especially car manufacturers. We've had an engine, we've had steering wheels, we've had cars out on the road for a long time. We haven't really known what's been going on with them until fairly recently. We've got stuff like the maps, telemetry, and what we want to do is to be able to connect the actual vehicles to the customers that are driving those vehicles. And this is the beginning, actually, of a culture shift that was mentioned earlier on, because all of the systems inside of Toyota, all of the systems inside of Ford, inside of all of these equipment manufacturers are all geared around producing stuff. They're not geared around linking the people to the things that we produce. And that's an opportunity for us, because as architects, we benefit from opportunities and crises. And in this case, we want to connect to the cloud. There's a lot of people out there. We can't control that. So all of the on-site technology that we have, that we've been used to, where there is a kind of understood limit to how much activity can go on those servers, suddenly becomes challenging. So we have an opportunity to go to the cloud. In manufacturing companies, this is the sort of split of things, as it were. We have research and development, and we have supply chain, we have manufacturing and distribution. And what I want to discuss a little bit is about the fact that from a software side, research and development looks like software development to me. That's where we do all of our development. And bizarrely, that's not where all the lean manufacturing stuff comes from. That's not where all the agile stuff comes from, actually. That is a bit undiscovered. Like most software development, it's kind of hard stuff that has to be done and is not repeatable, is not simple. So that's where we are, mostly on the left, research and development. But we've got supply chains. Now, for us, and for us in this room, supply chains typically are things like software as a service or software libraries, like we use databases or commercial libraries or open source frameworks. And then we have manufacturing. And manufacturing in software, in my opinion, tends to be around the deployment, the data center. And the data center is the thing which was under pressure. So we want to potentially change that manufacturing from a local data center to a cloud data center. And of course, the distribution from our side is the internet or the network. Now, these guys do their exercises in the morning, so they're agile in that sense, but they're not changing things here, okay? What factories do is they repeat things. We have the ideas in the software world, and factories stamp them out, go through a process, manage that process, make sure it's all repeatable, make sure it all works, and that's good. Now, one of the problems with this is that this doesn't work very well if it's not repeatable, if it's not scalable. So if I have to go to each of these factory workers and explain to them how to build that car, it's not good. We were taking up to 2 days to deploy stuff in the existing system. Now, I've got some drawings here of some pictures on the left-hand side. This guy is actually making bricks by hand. Now, that's fine. Artisanal work there for this guy. Everyone's happy. You know, he's got a job. But I would liken that, perhaps controversially, to the technologies on the right-hand side, which are all the sort of stuff that we were using before this. Very manual, so .NET, XML, we're using file systems for our content, using Subversion as our version management system. Everything was kind of manually deployed. It would take days to deploy something, not just to write it and test it and QA it and all those kind of things, but to literally deploy it into production. And then we're using monitoring tools on a per-server basis, like this SCOM stuff from Microsoft. We decided to change that to a different stack because we wanted to, what I would say is architect for the factory. We want to architect for something which is scalable, something which is automatable, something which is simple and visible to understand. And what we did there was we moved basically everything. And we didn't do any competition to say, is .NET use this many CPU cycles, or is Java slightly more, I don't know, more friendly? By the way, I've got like the other guy, I've got a background in Java and Clojure and some other non-JavaScript stuff. But I sat with Node for a few years, did some development in it, made sure it was real. I like to think that architects should actually touch stuff and make sure that it's valid and it's workable and that things actually do what they say on the tin. So I spent about a year with JavaScript without Node, about a year and a half with Node. I'm competent, I guess. I can write a few scripts. But what I found with Node, which was really interesting, was that you could run it, you all know this, but you can run it in incredibly small environments. So what you don't want to do is rely on a big, fat operating system underneath it. So if I want to spin up 10 nodes, for instance, then I don't want to be starting up 10 instances of Windows. I don't want to be starting 10 instances of Linux either. It seems a bit strange to us. So we realized that Node was very lightweight. We wanted to potentially spin up lots and lots of instances of them. And so we didn't want to go with something which was dependent on some very high-cost monolithic operating system. And I think Windows is that. I think Microsoft realized that. I think they're getting involved in the Docker project. They're getting involved in all kinds of Linux environments on their Azure platform. But Windows, for us, if we're going to get ready for the factory, then I don't like the look of their factory. That factory looks a bit heavyweight. It looks like it's kind of clunky to start things up. So we want to drop .NET and drop Windows. We wanted to drop XML. We were using XML as part of our content management system, but that was burning a hell of a lot of CPUs. And so we didn't benchmark this because the CPUs on the existing websites were just always at 100%. So I don't need to benchmark that. It's terrible. So it's quite easy for us to say, OK, let's just stop parsing stuff. If we use JSON, we don't need to parse anything. So that's really nice. I didn't need to argue too much about moving away from a disk to MongoDB, because we'd be getting disk fulls on a weekly basis, or we're getting disk outages on a weekly basis. So that was quite an easy sell. Moving from Subversion to Git was a bit of a headache for some people because they didn't understand what the benefits of Git were. But we worked with the developers to make them realize that actually pull requests, and the peer system was a lot more powerful than the Subversion workflow they had at the time. And we went from a manual deploy to an automated deploy. We use a stack from Atlassian. Some of you guys might know Confluence and Jira. And they also have a build system called Bamboo and a Git system called Stash. And the Stash, because we're a big manufacturer and we're scared of secrets going out of the world, then we have to have everything behind the firewall. So our code and our build systems are behind the firewall at the moment, at least. And so we use that, the Bamboo and the Stash stuff to do that. It supports pull requests and everything, which is very nice. So we suddenly get a lot of visibility into our code quality. And then we moved from these individual systems out to things like New Relic and log entries on Heroku, lots of add-ons to understand what's going on within the system. Suddenly we've got eyes on the system in a way which we've never had before. So that's been, we've moved from that kind of sludgy stuff out to this more automated environment. Okay, where do we build the factory? Typically, we build factories in the real world where there's a lot of water, there's a lot of energy, there's lots of available labor. So where do we build our factory on the cloud? Well, do we build it on the cloud? First question, of course. I mean, a lot of people are thinking, okay, let's just take a stack and do it internally. The problem with that for us was that we wanted to say, okay, we're going to go this way strategically, and if we do it like that, then unfortunately, or fortunately, with Toyota, you have to build a lot of consensus, and that's good, because if you're doing things together, then you're doing things in a strong way. But that means that to do this on-premise, to do it properly on-premise, would require a lot of investment, and the startup cost of making an internal cloud is quite high. You have to buy a lot of hardware, you have to get a data center, you have to invest in training people up in how to run that cloud. So actually, it turns out from a timeline, if nothing else, we couldn't afford to do that for this project. Something that we're considering for future projects, but an on-premise cloud at the moment wasn't possible. So we decided to go off-premise. Now, we do need to be aware that, or you maybe need to be aware that Toyota as a global corporation has relationships with lots of different companies. So we have relationships with Microsoft and Amazon. We're using Amazon all over the place. And we wanted to do a comparison then between essentially those three big flavors, Heroku, Azure, Amazon, some other smaller players like EngineYard, Joyent, Google App Engine, OpenShift. That was more of the on-site stuff. So why did we go with Heroku rather than those other two big guys? Mostly it was because we wanted a true platform as a service that we could adopt quite easily. We wanted to build something which was unaware of its infrastructure. So if we deployed Node.js to Heroku, then it would be unaware of the fact that it's going to Heroku. With Azure, it would be a bit more aware of it because it would be on Windows. If you go with Azure on Linux, you don't get the platform as a service. Amazon has this thing called Beanstalk, which can do Java and Node.js and Docker and these other things. But again, Amazon is really an infrastructure as a service company, does that very well. As it's moved up to platform as a service, there's a few gaps there. So for instance, the tooling around the Amazon Web Services isn't as strong as the tooling around things like Azure, actually, or Heroku, or these other guys. Because Amazon's APIs, if you ever look at them, there's like 1,000 APIs. Everything's a REST API. And from that sense, it's really good. If you're a tool builder, actually, if you're Heroku, then it's really fantastic because you have a platform to do that. But as a kind of shop where we're trying to essentially outsource this activity, again, it would be an extra cost for us to manage that. The other thing that we liked about it was the fact that there's a lot of ecosystem around Heroku. We could make add-ons, we could add MongoDB, we could add Elasticsearch. Just push a button, the add-on comes, and configure an environment variable, start consuming or start pushing to that database or to that search engine. So that's really nice. What we've leveraged also with Heroku is the fact that they do have platform APIs like Amazon, but that platform API is quite small. We have a system, for instance, that uses Node to deploy applications from one environment to another environment. The other interesting thing about Heroku is that it's an open source build platform. I don't know what the code is for Beanstalk. I don't know what the code is for Azure. But I know what the code is to deploy Node.js on Heroku. I can go to the GitHub repository. I can see what they're doing. And if I don't like it, I can change it. And in fact, we built our own build pack for Nginx to include some Google PageSpeed functionality. So that's really an advantage that we found with Heroku, was that if we didn't like their build packs, we could change them. In fact, we just used their vanilla Node.js package, but we have added some others. We can deploy in Europe as well. Most of these guys can deploy in Europe, so that's good. But the fact that we can keep our data in Europe helps regulations and helps people from being too scared about putting stuff that the NSA can see. Although, to be honest, the NSA looking at websites, that's OK. It's another hit. The other thing I liked about Heroku was that, coming back to that kind of monolithic operating system model, is that Heroku has some early insights into Linux containers. So everyone's awash with Docker now. Everyone's kind of happy about Docker, and Microsoft even, and Google, and all those guys are all getting into Docker as the basis for a platform as a service. But Heroku's already there, so they're already using these Linux containers. And they have a nice document called 12factor.net. It's a website which gives you all the kind of architectural guidelines you should follow, which helped us to prepare for the factory. The other thing that, and again, I don't know how many of you guys are from big enterprises, but if you look at these smaller companies like EngineYard or Joyent, then it's a difficult sell to say, OK, I've got this thing called Node.js, and I want to run it on this platform called EngineYard. And the executives, at least in our company, are like, what's Node? I haven't heard of this EngineYard. Isn't that where we scrap our vehicles? They just don't understand. So I could say instead, actually, we want to deploy it on this thing called Heroku, and it's owned by Salesforce. We already have a global partnership with them. OK, tick a box, move along. So essentially, I could come in under the radar, which was pretty cheeky, but it all worked out. I'll give you a little bit of an insight into how we run our operations now. We don't literally go to Italy and deploy 2 applications, or go to Spain and deploy 2 applications over with a helicopter. But what we do is we have, I mentioned at the beginning, or actually I think my friend there mentioned at the beginning, we have this monolithic application on site. And on site, we have one app or one cluster of apps that serve the whole of Europe. And what we do now instead is we have an application which we can clone and deploy out on a per-nation basis or a per-market basis. That's actually turned out to be really good for us, because we can then go to places like, we can try things out on markets like Portugal or Bulgaria or Azerbaijan. Azerbaijan has about 3 visitors a week, so we can try a few things out there, make sure it works. We've got a couple of dynos over there, and then we can say, OK, right, now let's roll it out to Greece, let's roll it out to Portugal. Or we can take a bigger risk, and we can say, OK, let's make a change on the French website, and it's isolated only to the French market. And that's really helped us, because in the past, we've been stuck with these disk fulls or these out-of-memory errors, or if we lose a machine in the cluster, we're suddenly down to 60% of our capacity. With this system, instead, we can just say, OK, if there's a particular campaign going on in Poland or Russia or Finland or whatever, we can just turn up the dynos for that market, either manually or through some automated system. And that's what I would call manufacturing these websites. So we're going more and more towards that model of having everything dedicated towards a particular marketplace from the top to the bottom. So the web server, the middleware in the node, the databases, everything all the way down the stack. At the moment, we still have some things that are on-premise and that are kind of monolithic, and we're breaking those out. As we gradually break those out, we're following the same model. And this is really a key thing for us, is the ability for us to spin up lots of different clones of the same application in many different markets. And we know that they're all going to behave pretty much the same way, but we can configure them going forward as well. So for instance, if the Italy guys want to integrate with their dealer management systems or their order management systems, then we can have a special environment variable or a special add-on that plugs into their application that doesn't plug into the other markets. So this is really a powerful option for us. I've kind of run out of steam, so I'm done a little bit early. So I would be happy if we could take a few questions.
Any questions? Can I ask, how has the workflow been? Are people, like for people at Toyota, had they used, because I know, for example, for me, most of my work that I've ever done with Heroku has been really like hobbyists. And so for me, it's like, if I want something, just want to spin it up, don't worry about it, just go to Heroku. But like, for you guys, had you had engineers who had experience with the platform already, and did that help with transition?
We had no experience with the platform at all.
Oh, okay.
It was I mean, and that's really the good thing about it, because I had a discussion actually with the CIO last week about it, and he was saying, yeah, but in the end, you need to log on to these machines. You need to get into this platform as a service. You know, you can't just buy these platforms. You've got to go and really discover everything about them, which is great for you, but, you know, but actually it turns out not to be true. You can't actually log on to any of the machines in Heroku. You can't literally touch them. It's impossible to touch those things. So we can't fiddle with them. And we can't know exactly what's going on in there. Right. All we know is that we can run up exact copies of them and diagnose things. We can get hands onto them. But we haven't had any experience beforehand of the deep platform, and we haven't really needed it, because actually the surface area of Heroku is quite small from an engineering perspective, and actually the workflow has been quite simple. The developers are developing in a completely... Heroku has a concept of organization, so you can have an organization which is a development organization for the websites, and another organization which is for production. So that goes beyond the kind of hobbyist. They have an enterprise package where you can set up an organization called production, organization called development. All the developers can have their roles and their activities, and they can spin up their dynos in complete safety in the development environment. When they're ready to go, we have one little program which will say, okay, taking your dyno, your exact, like the Docker file or Docker image, take your image out of that development environment and plonk it exactly into production. So that's the workflow we have in terms of promotion. But the development workflow is basically just a standard kind of do everything on your local machine using JetBrains or WebID, you know, whatever you want to do, Sublime Text, and then push it out to Heroku in Git, make sure it all works, put it into some test environment so the users can check it out, and then we promote it to production.
You haven't run into, and not having full control over the machine as you would otherwise, have you run into any issues like where it was hard to install something, or when something went south, it was hard to detect or mitigate in a way that you wouldn't have if you actually had physical control as much as you at least can have in the cloud of that machine, not through Heroku?
This is often the question you get, is that, oh, you don't control this stuff.
Right.
You know? But actually, you don't want to control it. You really don't want to control this stuff. As long as you can get eyes on it, you know, so there's dashboards, they've got lots of things like Liberato, New Relic, log entries. You can inspect what your code is doing. And like I say, you can start up an exact copy of your dyno, and you can look into that. You can look into the copy. And if that's not doing the same thing as production, then things are definitely going south. But we haven't had any problems like that. We've had a few problems with our APIs, where we've had to talk to the Heroku guys and have a support call to say, we've made a deployment, but it doesn't seem to have worked for all of these cases. Can you help us out? That's probably the only case it's ever really happened, and I think it's happened twice in 3 or 4 months.
Okay. Yes. Sorry.
Sorry.
I have a question.
What's your question, Tim?
We're talking amongst ourselves here. You know, you can also put your hands up.
What are some of the tools that you're thinking of building in the future? Like, what are you excited about as far as building to automate all your Heroku processes?
Yeah, thought you'd ask that one. Well, there's a few things. I mean, we want to build basically the tools that we want to build are around release management. Now, I'm not sure. I talked to some of the Heroku guys as well. They've got plans for building release management tools. We have some ideas about what we'd like to see in those tools, and we'll probably build them ourselves. But it's basically about saying, OK, well, I'd like to know which version of the app is in production at the moment across the entire organization. At the moment, we have to go into each app and have a look at that in detail, and that's a bit annoying. So I'd like to have a dashboard that could show the entire production environment. I'd like to also see, for instance, why is this one application different from those applications? If it was intentional, that's great. We did it deliberately. But if it's not intentional, then I want to know about it.
We have one. I think we have time for one more question before we go into break.
Hello. I've got not quite technical question, but I'd like to ask how you plan the budgeting for your cloud infrastructure. If you go to CEO, you have to provide some figures. So is there a tool or something that helps you?
So I don't understand. Can you repeat the question?
Well, if you have to plan the budget for your cloud infrastructure in Heroku, how would you approach that?
OK, you have to do that, actually, of course. So what we did was we said, OK, we did some benchmarks. We did some benchmarks to price out the infrastructure, basically. We took the existing website and we said, OK, what's the number of hits we get every month? Let's run up a basic version of Node, run it on a local machine, see how many hits we can sustain on Node. We ran that on Amazon. We ran that on Heroku as well. And we say, OK, there are a bunch of add-on tools for load testing as well through Heroku, and you can get on the cloud, of course. So we run some benchmarks, and we say, OK, right, well, this instance of Node can handle, for this country, let's say Germany, we've got 2 Node.js instances. It can handle this much traffic without sweating, so everything's good. And then we can say, OK, well, Germany's one of the biggest markets, so everything else will at least match that. So we can go with 2 dynos everywhere at the Node.js layer. Maybe it's 2 dynos at the Nginx layer. And then we can say, OK, if we've got 30 countries, we'll just cost out there. Then you're going to pay for add-ons like MongoDB, like Elasticsearch, and they're all well priced up front, so you can do those budgets. So in fact, it turns out to be relatively straightforward with Heroku to do that. It's more complicated, I think, with Amazon, because all the component pieces are quite difficult to all wrap your head around. And then you find, oh, actually, I need this, I need that, I need this. So I would say that of course, it's possible to do with Amazon. And we already use Amazon for a number of things. But it's more difficult to predict, I think, with Amazon than with Heroku, because it's not so simple to package those things up. So yeah, good question.
OK, we've hit break time. So thanks to Ray for...
Thanks very much.